Hi guys, please like, share and subscribe and contact this number if you want lectures related to any CM, CS or CB subjects. Thank you. Okay, so by now we have largely covered a lot of utility theory, and now I want to talk about something which is much closer to our hearts as actuaries, that is insurance. So I'll be taking a utilitarian perspective to insurance. Okay. I'm addressing a fundamental question here, that why does an individual or an entity, okay, let's just call them policyholder, why does a policyholder buy insurance? Why does someone buy an insurance? The simple answer is that they buy an insurance policy because they are risk averse. So risk aversion is the primary reason for why insurance is bought by individuals. Let me explain this in more detail. Okay, let's say there is a person, and let's just say they can suffer a loss of 1500 pounds. Okay, so there is a risk event with which so there is some risk event with which they can incur a loss of 1500 pounds, and the probability of loss is 10%. Okay, so in 90% of cases there will be no loss, right? So this is the risk event that we are talking about. So what is the expected loss? So the expected loss under the risk event is actually equal to 1500 into 0.1 plus 0 into 0.9, that is 150 pounds. Okay, but if the insurer if the insured, that is the policy holder, is risk averse, they would be willing to pay a premium which is higher than their expected loss. For example, 200 pounds. The only reason that an insured is willing to pay a premium which is higher than their expected loss is because they are risk averse individuals. Okay, what this means is that they are okay incurring this loss of 200 pounds with a 100% probability. The probability of this would become 100% once they pay the premium, rather than incur such a big loss of 1500 pounds with 10% probability. Okay, so they are so afraid of this 1500 occurring, this loss of 1500 occurring, that they are okay avoiding this and paying a premium and incurring a loss of 200 pounds with a certainty. Okay, this is sort of a certainty equivalent sort of notion. Okay, and they are willing to do this even if this premium is higher than the expected loss that they are about to incur. If they were a risk neutral individual, they would have gone for this. They would have been okay facing this risk event and taking up this gamble, because they would have realized that the expected loss in this case is much lower than the premium that they would be required to pay under insurance. But the only reason that insurance sells in real market and the premium is higher than the expected loss, that is what makes insurance profitable for insurers, is because most individuals are risk averse. Okay, so and you would notice, if you would remember the theory from CM1, the premium that the insurance company charges is almost always higher than the expected loss. Why? Because the premium not only covers for the risk itself. Okay, the premium which only covers for the risk itself is called as the risk premium, or we used to call it the net premium in CM1. Okay, that covered for this 150, just the expected loss. Okay, that's one part of the premium. There is more to premium, there is more to gross premium. It used to cover for the expenses and for the profits of the insurance company. So typically the gross premium is much higher than the net premium itself, which just covers for the risk, because it covers for more than the risk, it covers for the expenses and the profit margins as well, right? And because the insurance company will charge a much higher premium than the expected loss, the insurance policy holders will only buy them if they are risk averse. Okay. So, that is the general idea I wanted to talk to you about. Now, when a policyholder is risk averse, they are okay paying out a premium which is higher than the expected loss under the risk event. Okay. So, that is the idea. Now, how do we find out the maximum premium that the policyholder is willing to pay? That is the question I am asking. How do we find the maximum premium that they are willing to pay? For that, again, I want to get to the fundamental question from a utilitarian perspective. When will an individual buy an insurance policy? They would buy an insurance policy if their utility or if their expected utility without buying the insurance is lower than their utility when they buy the insurance. Okay. So, let me write it like this: utility without buying insurance is lower, less than or equal to, as compared with the utility with buying insurance. Okay. Which means, let us just say that the policyholder starts with an initial wealth of A, okay, and I want to find the maximum premium that they are willing to pay. Let us call the maximum premium as P, okay, and the loss that they incur under the risk event, let it be X, which is a random variable. This is a random variable. These are fixed values. So, X will have a certain distribution and we will have to calculate the expected utility. Okay. So, an insurance policy holder will only buy a policy if the utility without buying insurance, that is the expected utility without buying insurance, what will that be? That will be their initial wealth minus whatever loss they incur under the risk event and not pay the premium, right. This utility is lower than the utility under insurance, that is their initial wealth minus the premium, and then they don't the risk event does not occur. So, this is the sort of equation that we are dealing with, and if you want to find the maximum premium that the policyholder is willing to pay, then we can say that the utility, the expected utility with buying insurance must, if not greater, it must at least be equal to the utility without buying insurance. Okay. So, it must at least be equal to this, and when this equality is satisfied, because usually see, the point is that I want some profit, right, as an insured. So, with buying insurance it should give me a higher utility, but even if it gives equal, I am okay, right. So, that this P is actually your maximum premium which satisfies this equation. Let us take a numerical example now. Let us just say an insurer, okay, no, not this one, let us first talk about the insured. Okay. So, let us say consider an individual with the utility function as ux is equal to root of x and the current wealth level of 15,000 pounds. Assume that this individual is at a risk of suffering damages which are uniformly distributed up to 15,000, then the individual's expected utility is, so first of all I want to talk about this fact that the utility function of the individual is root over x. Now, I want to show you that this is a risk averse individual, which just means that the second derivative of the utility function is actually negative. So, if you take the first derivative, it will be half x to the power of minus half. If you take the second derivative, it would be this half will come down, minus half will come down. So, minus 1 by 4 x to the power of minus 3 by 2, okay, which is negative. So, we have a risk averse individual, which would mean that the individual would be willing to pay a premium which is higher than the expected cost under the risk event. What is the expected loss under the risk event? Well, you have the loss which follows a uniform distribution from 0 to 15,000, right. It says that the damages are uniformly distributed up till 15,000, right. So, this is the distribution. So, what is the expected loss, or what is the expectation of X? It's 7,500. This is the expected loss. So, this individual must be willing to pay a premium which is greater than this expected loss. Why? Because they are a risk averse individual, and that is what I am going to show you now. Okay. So, now let us just try to find the maximum premium that they are willing to pay, and I will show you that it will be greater than the expected loss that they are about to suffer. Okay. So, maximum premium, let us implement this formula, it is fairly straightforward. So, the expected utility without insurance. Okay. How do I find this? So, the distribution is uniform. So, continuous uniform, I will have to take an integral. Integrating over the entire range, let us work in units of thousands. So, integrating over the entire range of X, we take the utility function, which is root over a minus x. So, that is 15 is your initial wealth, x is your loss. So, your wealth after the loss is 15 minus x, and I am taking the utility on that. So, that is 15 minus x multiplied with the probability function f x x dx. Okay. And this must be equal to the utility which is a minus p. So, it will be root over 15 minus the maximum premium. Okay. So, now let us just solve this. So, the range for x is 0 to 15 as we discussed, root over 15 minus x. So, I will just write 15 minus x to the power of half. And what is fxx? Fxx just becomes, so it is just equal to 1 over 15 dx. Okay. And this is equal to 15 minus p. Okay. Now, if I solve for x, so if I solve for p, that will give me the maximum premium. Okay. So, let us just integrate now. How do I integrate? It will just become half 15 minus the integral will be 15 minus x to the power of 3 by 2 times 2 by 3 into 15, and the values I have to put in are 0 to 15. This is equal to root over 15 minus p. I want to solve for p. Okay. Now, let us just put in the values. So, at 15 this whole expression will just become 0. Okay. And since x is negative, this will be negative. Okay. So, this entire expression will become 0 at 15. At 0, this expression will be equal to minus of minus. So, that will just become positive. So, 2 by 15 times 3 is 45, and 15 to the power of 3 by 2. Okay. This is equal to root over 15 minus p. Okay. Now, I want to solve for p. Okay. So, now let us just see how can I find the value of p. So, if I solve this, this just becomes 2.582. Okay. And this is equal to root over 15 minus p. Now, I will square both sides. So, your p will be equal to 15 minus 2.582 squared, right, which will just become 8.333, and this is in units of thousands. So, the maximum premium that you are willing to pay becomes 8,333,000 pounds, which is higher than your expected loss. Okay. And that is how the insurer will be able to make a profit as well, because their expected loss will just be 7,500, but then they will be making money because they can charge a higher premium. Okay. The simple point I am trying to make is that a policy is only sold if the maximum premium that the policyholder is willing to pay is higher than the minimum premium that the insurer is willing to charge. Okay. This has to go through. If the premium that the insurer is willing to charge is higher than the maximum premium that the policyholder is willing to pay, the policy won't be sold. Okay. Simple point. Now, what I want to do is I want to work the insurer's side of this as well, like for a separate contract. Let me show you how it works for the insurer. Okay. So, let me first give you an equation. So, an insurer, if you want to find the minimum premium that the insurer is willing to charge. How do you do that? Let's say the initial wealth of the insurer is again A. Let's say the premium that they are willing to charge, that I want to find out, minimum premium is P, okay, and then let's say the loss under the risk event is X, okay. So I have to work out with insurance, utility with insurance, and utility without insurance, and the insurance will only be sold if the utility with insurance is greater than equal to this, okay. So then what will this be? With insurance it would obviously be an expected utility. So expected utility, you start with an initial wealth, you earn the premium, but you pay for the losses as well, okay. And expectation, why am I taking it? Because X is a random variable. Without insurance, you don't sell insurance, so you don't receive a premium, you don't pay for any loss. So it's utility of just the initial level of wealth. This is the equation. If this will be satisfied, then only the insurer will sell the insurance. So if you want to find the minimum premium, again you will focus on the equality, okay. Okay, you will focus on the equality, right. Now, so this is the simple point. Now, if I want to find the minimum premium in a particular case, let's just take this example. An insurer with an initial wealth of £2,000 and a utility function that is log of X is designing a policy to cover damages of 500 that occur with a probability of 0.5. So damages of 500 can occur with a probability of 0.5, a discrete distribution. Calculate the minimum premium that the insurer can charge for the policy. So I'll just implement the equation. The expected utility under insurance should be equal to the utility without insurance, okay. So what is the expected utility if I sell the insurance? It's log of my initial wealth plus the premium that I receive minus 500 in 50% of the cases and minus 0 in 50% of the cases. So it's basically this X can take a value 500 in 50% of cases and 0 in 50% of the cases. So it will just become log of 2000 plus P minus 500, that is 1500 plus P in 50% of the cases, and then log of 2000 plus P in 50% of the cases when the loss is 0 multiplied with 0.5. This is equal to utility of A. So this is just log of what is the initial wealth? 2000. Okay, so this is how it works. Now what I do is I take the 50% common, so it's 0.5 log of 1500 plus P plus log of 2000 plus P. Okay, and this is equal to log of 2000. Let me change the color of the pen because it's getting somewhat confusing. So let's use green. Okay, yeah. So it's 0.5 I'll send on the other side. So it's log of, and these two I'll add. So it's log of 1500 plus P multiplied with 2000 plus P. Okay, this is equal to 2 times log of 2000. So if I just multiply it with 2, 2 can go in the power, and log will just cancel out. So this is your equation, and this will lead to a quadratic equation which will be equal to, let me just give you the quadratic equation, which will be P square plus 3500 P minus 1 million, okay, is equal to 0. This will be the quadratic equation. You can solve this and get it. Okay, so if I want to solve this, it's simple. I have to apply the quadratic formula. So P will be equal to minus 3500 plus minus root over, so minus b plus minus b square, which is 3500 squared, minus 4 AC, so 4 into 1 million, but this is also negative, so this becomes positive, divided by 2a, so that's just 2. So it will give you two values, which will be equal to minus 1750 plus minus 2015.56. You're not concerned with the negative value, premium cannot be negative, so your premium will come out to be equal to 265 pounds and 56 cents, 56 pence. This is your premium. That's how you find the premium of the minimum premium that the insurer is willing to charge. Okay, so that's all for this topic.